In example 1, we want to find the vector that's perpendicular to two other vectors, 5, 1, 4 and negative 1, 0, 2. Then we're going to verify that result by using the inner product, which is also called the dot product. To find a vector that's perpendicular to two other ones, we need to use the cross product. To do that, what I'm going to use is the determinant of a 3 by 3 matrix. So I'll have vector I, j, and k. That'll give us our x, y, and z components. And then I'm going to list the first vector 5, 1, 4 here, and the second vector negative 1, 0, 2 here. What I'll do then to find the determinant of this 3 by 3 is break this down into some smaller 2 by 2 matrices. I'll write vector I, and we always do plus. You can put a plus sign here if you really want, not totally necessary. A minus sign, and then a plus sign. And you'll just list I, j, and k in order. We're going to write down these smaller 2 by 2 matrices, and how we're going to do that is we're going to imagine that we cross off the line that has the letter in it, so we're looking at I right now, and the column. And we're actually left with a smaller 2 by 2. That smaller 2 by 2 is what's going to go here. Now that's a 1 and a 4, not a 14, and then a 0 and a 2. Okay, let's see here if I can, whoops, shouldn't have undone that. Let's see here if I can erase this line, and this line. And then we'll change colors here for J. So for J, you're going to take the row that J is in, the column that J is in, and then you're going to see 5, negative 1, and 4, 2, and that's going to be the new, or the 2 by 2 matrix on the right-hand side that belongs with J. So I'll write 5, 4, negative 1, and 2 there. We'll see if we can erase those by still keeping our matrice there. For the last one, we're going to look at K now. We're going to cross off the row that contains K and the column that contains K. And what we're left with is another 2 by 2 matrix, which is 5, 1, negative 1, and 0. What we'll do now is we will try to find the determinant of each one of these separately. So I know that my first one is positive here, that's vector I. To find the determinant of a 2 by 2, what you're going to do is you're going to go upper left to bottom right and multiply those together. So that'll be 2. And then we're always going to subtract the upper right to bottom left. Now 0 times 4 is just 0. Then we'll have our minus sign, vector J. We'll do the same thing here. So we'll do 5 times 2, that's 10, minus, and then now we're going to need upper right to bottom left, so that's actually going to be negative 4, plus vector K. We'll do the same exact thing here. So we got 5 times 0, which is 0, minus negative 1 times 1, which is negative 1. Then all we need to do is a little bit of simplifying work, and we'll have found our third vector. So 2 minus 0 is 2, so our coefficient for the unit vector I is 2. And then we'll have J here being 10 minus negative 4, that's 14, and there's a negative sign out front. So we'll have 14 here, or negative 14 with vector J. And then we have 0 minus negative 1. So 0 minus negative 1 is just 1k, or you can write just k. To write that vector as a vector ordered triple, we're just going to take the coefficients of each one of the unit vectors, and those will be our x, y, and z components. And if you want, you can name it something new like the resultant vector or whatever. But anyways, hopefully, if we actually graphed these in three-dimensional space, hopefully this vector r would be perpendicular to the other two. Now, these two vectors don't have to be perpendicular that I just underlined right here. It's just vector r with each one separately. So to check our work, what we're going to do is we're going to take each one of those vectors. Let's start with 5, 1, 4. And we'll do the inner product or the dot product with the resultant vector, which is 2, -14, 1. And this is just a double check to make sure we've actually found that third vector that's perpendicular to the other two. So to find the dot product, we'll do 5 times 2, multiply the x's, that's 10. 1 times -14 is -14. And 4 times 1 multiplying the z's is 4. 10 minus 14 plus 4 is 0. So that's good for us. That means that our new vector r is at least perpendicular with this first guy right here. Now we're going to pick the second one, which is -1, 0, 2. And once again, we're hoping that that vector is perpendicular with our resultant vector. The original vectors do not have to be perpendicular. Most times they're not. It's just each beginning vector that we start the problem with has to be perpendicular with our new one. So if we find the dot product here, we'll do -1 times 2, which is -2. Those are multiplying your x components together. Your y components, 0 times -14 is 0. And now your z components, 2 times 1 is 2. And if we do -2 plus 0 plus 2, we get 0 as our dot product, which means that those two vectors are perpendicular.